Alright, so what could I do with this if I wanted to simplify it? Could you put, can we multiply this all out? It's all multiplication, so 6x times 3 times 24x, what is that? Can you guys do that for me? You can use your calculator if you want. 6x times 3 times 24x. Okay, 432x squared, and then this is still 3x squared plus 1 squared. Okay, so that's what this whole part simplifies to. Alright, over here I have plus 24, and what I'm going to do, you might not understand yet, is if this is a power of 3, that means there's three factors of it, correct? So I'm going to do this. I'm going to do 3x squared plus 1, there's one factor, times 3x squared plus 1 squared. Would you agree with me these two things multiply to be 3x squared plus 1 quantity cubed? Yes. Anybody know why I might choose to write it like that? Because then I have that these are the same, and that's going to help me because in a second when I do the double derivative, because if you look in the instructions of the problem, it's going to make my life easier if I have just two things. Alright, just trust me for right now. So what I'm going to do in order so that I can have just something in front of 3x squared plus 1 squared like this, is I'm going to distribute this. Can you do that for me? So now I have 432x squared, 3x squared plus 1 squared. I haven't changed that. What is this distributed equal? (72x squared plus 24 times 3x squared plus 1 squared. Okay. Now, this is an algebra concept. We call it sometimes chunking, or we're really using the distributive property. So what is going on here is what's in between these two groups of things is an addition sign, correct? So what that means is I can add together these two groups of things. I can add what's in front of this term and what's in front of this term together. Why? Because they are both in front of a common term. What would happen if you added these two highlighted things together? What would you get? If I had 432x squared plus 72x squared plus 20. Okay. 504x squared plus 24 of 3x squared plus 1 squared. Okay. I am going to put a box around this because this is a nice simplified
Why is it 3x? Wait. Oh, okay. So you did distribute.
I'm adding like terms here, guys. I'm just adding these together.
Okay, yeah.
It's like this. If I had sidebar up here, if I had 7x plus 8x, what you're really doing is you're really doing 7 plus 8x, right? So I'm saying the same thing. If I have a bunch of gobbledygunk, 3x squared plus 1 squared, and another bunch of gobbledygunk, 3x squared, I can add those two together. It's just that it's way simpler when it's 7 and 8. Yes, it is. Alright, so would you box this? This is the first derivative. Whoa.
That's quite something.
Now wait till we get to the second derivative. No complaining. Okay.
You're not allowed to skip that one then?
What?
You're not allowed to skip the second derivative?
No.
Can't like scribble all over a paper and go like a hangman.
Nope.
With the square root.
Nope. Hey, that's it's not difficult enough yet. Okay. So let's do the second derivative now. I'm looking for another piece of paper because Oh, here we go.
Cameron?
Yeah.
Wasn't the first derivative the 24x to the 3x squared plus 1?
Yeah.
Did we already do it already?
Yeah, shouldn't that one be the second
Oh,
derivative?
oh, crapola. Hold on, let's think. Let's just check. First, oh yeah, I did.
Okay.
Phew! Okay,
Good. Awesome.
that's okay, we'll get the more difficult one in a little bit. Okay, sure. Alright, so that is how you find the second derivative.